All right, section 4.3 is on maxima and minima, or as normal people call them, maximums and minimums. All right, and I'm going to be looking at a lot of graphs in this section. These are posted under our resource tab. They are our chapter 4 graphs, if you want to print that out or just have it up on your computer screen as a reference. All right, so we're just going to focus on looking at what an absolute maximum or minimum means and then identifying them from a graph. All right, so our definition of an absolute maximum, and we're going to see later that this is in contrast to what we call a local maximum. All right, so we're not going to talk about local maximums in this section, but we will a little bit later on. All right, but an absolute maximum is, f of x has an absolute maximum at x equals c if f of c is greater than or equal to f of x for all x in the domain of f, which probably makes little to no sense as you read that. All right, so the best way to think about an absolute maximum is to think about a downward opening parabola. Okay, and that absolute maximum is going to be at the vertex. Okay, so the c they're talking about is that x coordinate, and f of c is the associated y coordinate. All right, and it's an absolute maximum because f of c, the y coordinate at the vertex, is greater than or equal to all the other y coordinates for the rest of the function, all other f of x values for all x in the domain of f. All right, so it's just kind of like the peak, the highest y coordinate that you get. All right, likewise, we can have an absolute minimum. And again, this will be easiest to think of as like a regular upward opening parabola. All right, so the vertex here and its associated y coordinate is an absolute minimum. All right, so because all of the y coordinates, f of c is less than all of the other y coordinates for this entire function. All right, and we call it an absolute minimum because it's absolutely the lowest y coordinate that we can get on this function. All right. Okay, so we're just going to go look and see if we can identify these by looking at some crazy graphs. All right, so chapter 4 graph number 1. All right, so again, if we're looking for an absolute maximum, we're looking for the absolute biggest y coordinate achieved by this function over its entire domain. And that's going to be this point over here on the right. 6 is the biggest y coordinate we get, so we would say that the absolute maximum is equal to 6 at x equals 10. So we always want to say what the maximum is, and then what the x coordinate is. Alternatively, you could also say that the absolute max happens at f of 10, which is equal to 6. Okay, so either one of those two, but you need to identify the x and the y coordinate. All right, and then the absolute min, we're looking for this smallest possible y coordinate that we get over this whole function, and that's going to be this point down here at the cusp. All right, so we would say that the absolute min for this function is equal to a y coordinate of 1, and it happens at x equals 8. All right, and so all the other points don't really matter for absolute max and absolute min. All right, for a function like x cubed, when we're looking for the biggest possible y coordinate, when that graph goes to the edge of the graph paper, we know it keeps going forever. So any y coordinate that you might find and think that it's the biggest, this arrow is going to keep blowing past it. So this graph has no absolute maximum. And likewise over here on the left, because it keeps going forever in the negative direction, any y coordinate that you think is the smallest, it'll get lower than that. So we're going to say there's no absolute minimum. Okay, so it's not necessary that a function has an absolute max or an absolute min. And then we have something like one of our trig functions. This is the graph of cosine. All right, and this one, the biggest y coordinate that it achieves is 1, and it does it repeatedly. Okay, and in our definition of an absolute max, it said f of c was greater than or equal to f of x. So it's okay for an absolute max or min to be repeated over and over and over again. Okay, so we would say that all three of these, and really we know there's an infinite number of them, we're going to say that the absolute max is equal to 1, and it's happening at, let's see, negative 2 pi, 0, 2 pi. These are even multiples of pi. And likewise, our absolute minimum happens repeatedly at the odd multiples of pi. Okay, so our absolute min is equal to -1 at odd multiples of pi. Okay, so a function can have no absolute max or min. It can have repeated absolute max and min. All right, so the absolute max on this one is pretty straightforward. That's this one at the left endpoint over here. Our absolute max is equal to 2 at x equals 0. All right, and the absolute min, we're kind of drawn to this section of the graph over here for our min. All right, so it can't be this filled in dot here, not this, because the y-coordinates get lower than that in this section of the graph. Okay, and we can't say -2 because it doesn't actually achieve that. Okay, so that open circle means we don't actually get that y-coordinate. And so the open circle implies that it keeps going all the way up to -2 but doesn't actually get there. And so any low y-coordinate you might pick, like -1.5, we could say, well, it might get to 1, it does get to 1.9, -1.9. Okay, what about -1.999? Okay, any number of 9s that you're going to list on there, I could always come and add one more 9. Okay, so it could keep getting lower and lower and lower, but never actually getting to the value of 2. Okay, so this one actually has no absolute min, because that open circle kind of precludes it. All right, and then this one also has kind of the same trouble with the absolute min. The absolute max happens here at this peak. But the absolute min, this graph is implying an asymptote. It's having this asymptotic behavior as it goes towards the x-axis. It's getting closer and closer and closer and closer and closer and closer to the x-axis, but it's never actually getting there. Okay, so any tiny value just above the x-axis that you might pick to be the lowest, the minimum y-coordinate, I could come in here and put another 0 in there. I could always make an extra 0 in there. Okay, so you can always shove an extra 0 in there. So this one likewise has no absolute min. Okay, so at asymptotes and at those open circles, it kind of gets a little bit weird. All right, so something we're going to notice for all of these absolute extrema, they happened at one of 3 places on the graph. A lot of them happened at endpoints for us. So like the first one, we had our absolute max was over here at the right endpoint. Okay, so if a graph stops at a solid circle, we might have an absolute maximum or minimum there. We also saw that we got absolute extrema at a place where f prime of x is undefined. This graph had a cusp, and that ended up being the place where we got our lowest y-coordinate. Okay, remember that f prime of 8 does not exist. It does not exist. How about we, there we go, does not exist because we didn't really have a tangent line here. We said at any corner or cusp, the derivative is undefined. So a derivative being undefined can cause an absolute extrema to take place. All right, and then also, for our cosine graph, we saw that our absolute extrema happened at these little hump places on the graph. All right, and those are places where the derivative is equal to 0, right, where we get these horizontal tangent lines. Okay, so that's another place where you might have an absolute extremum. Okay, places where the derivative is equal to 0. Okay, so sometimes it happens at the endpoint, but sometimes you can maybe predict where these places are going to happen based on the derivative. Okay, so we're going to focus on those 2 derivative criteria in the next video. These 2 things, where the derivative is 0 and where it's undefined, we call those the critical points of the function because they are places where you can get an absolute maximum or an absolute minimum. And that's what I'll do in the next video.